There is strong competition in modern production engineering, which is expressed above all in increased costs and time pressure in all phases, from assembling the automation solution to maintaining the production systems. For systems and machine constructors, it is decisive to be able to guarantee high availability for their products. Let us take a fictitious fault in the system. A standard alarm system informs the operator of a symptomatic fault by a display on the HMI device. Now, to determine the cause of the fault, for example, which missing step enabling conditions are holding up the process, you need a programming specialist who has to analyze the user software with a programming device. This sort of procedure usually results in long standstill times. This is where process diagnostics comes in. It is built into the user software, and it not only rapidly informs you of a fault, but also locates it automatically, and thus helps in troubleshooting. The time-intensive employment of a specialist is no longer necessary, because all the information is displayed to the operator on the HMI device. And the operator doesn't need to have any programming know-how, nor use any programming devices. In the sections that now follow, we will be demonstrating how Simatic fulfills these requirements. You can define diagnostics as being the determination of a faulty function through monitoring and evaluation of the characteristic values of a system. If the evaluation of these characteristic values throws up a critical value, the cause and location of the abnormal state is determined and displayed. In the course of the process, the significant symptoms captured by the monitoring system are analyzed and the cause responsible is determined. Considering that in practice there is a lot of ambiguity between the cause and effect, the diagnostics process can be a very complex one, which is why it is necessary to have extensive know-how and experience in processes and possible faults. Technical diagnostics is integrated in an overall maintenance strategy whose primary task is to ensure high availability, especially in production systems. In the corrective case, in other words when a unit fails, the system must rapidly display the fault, locate its cause as precisely as possible, and support the operator in clearing the fault. The savings potential is highest here because standstill times in the production process can be reduced. The preventive case is based mainly on a time model. Here, using logistics tools based on time intervals, operating hour meters, etc., a warning is purposely triggered and servicing carried out reliably. The consequence here is that you might waste the service life of the unit replaced, because it might well have continued functioning a lot longer. The predictive case is based on a status model. This means that optimally the operator receives a clear and explanatory warning in good time that a fault might occur in a unit or system in the near future, or an indication is given of the remaining expected service life of the equipment. This means that practically all additional costs are eliminated. This case requires extensive knowledge of the process, because to ensure a meaningful prediction, often very many statuses and characteristic values have to be evaluated. In this respect, automatic diagnostics systems based on know-how and status are just beginning to find universal employment in the production industry. The tasks of system and, above all, process diagnostics with Simatic, which is the topic of this demonstration system, are for corrective cases. The diagnosis of a fault is normally based on which components of a system or machine are diagnosed. We therefore differentiate between two types of diagnostics: system diagnostics and process diagnostics. System diagnostics covers the monitoring functions that concern the correct functioning of the components in the automation system, which includes everything from S7 CPUs and function modules to network components and intelligent sensor interfaces. If a fault occurs, this could be a programming fault, module failure, access failure, etc. Then this is stored by the CPU in an internal diagnostics buffer. The service staff can run a fast and targeted fault diagnosis via PG functions. Also, the display of system faults on HMI devices requires only a small amount of configuring. In the case of a system fault, the operating system of the CPU interrupts the normal run of the program and automatically calls the appropriate fault OB. The programmer can now selectively react to each system fault individually. Process diagnostics now captures all the events, processes and components going beyond the controller in a system process. These can be defective sensors or actuators, hindered movements, or unfulfilled blocking tasks, for example. Process diagnostics cannot be automated in the same way as system diagnostics. It is system-specific and therefore cannot be built into the hardware or software like the system diagnostics. Process fault recognition requires a different monitoring strategy for each machine or system, and can only be implemented by the manufacturer of the system. The engineering tools support the programmer here by generating an individually monitoring program that is incorporated in the program processing. Integration of process diagnostics into HMI devices requires only a minimal amount of configuring thanks to ready-made standard masks. Let us summarize this. Due to the high hardware availability of today's automation components, the emphasis of the diagnostics must very clearly be put on process faults. The sense and purpose of process diagnostics is to quickly and reliably display the fault and its causes. We will now have a specific look at the Simatic products and tools that make process fault diagnostics possible. Process diagnostics in Simatic includes different additional products that are integrated by TIA into the individual overall solution via optimum system interfaces. These then provide a consistent interaction between the Simatic languages, the options packages, and the HMI configuration tools. Process diagnostics in S7-300, S7-400 or WinCC systems is embedded in the three languages S7 Graph, S7 Graph, and ladder, function block diagram or statement list. The Simatic languages S7 Graph and S7 Graph support process diagnostics anyway. In other words, they provide the option of programming the relevant monitoring conditions directly next to the program logic in the sequencer and status graphs. If the user program is written in ladder, function block diagram, or statement list, then the S7-PDiag option package has to be integrated into the Step 7 development environment. Using this, you configure the signals to be monitored, plus the monitoring regulations and the associated message texts. On top of this, S7-PDiag automatically generates the required monitoring blocks, which contain the complete monitoring logic and mechanisms for transfer to the HMI devices. In the languages listed, the configuration is stored via a system-wide interface in one common database on the configuration computer. This circumstance permits single-step configuration of the process diagnostics. In other words, all the configuration tools involved automatically access the database and take the relevant data or store the data required for other packages there. The visualization tools for ProTool or ProTool Pro and WinCC are enabled in each case by the Pro Agent option package for seamless integration of the process diagnostics into the HMI system. This contains ready-made and pre-connected standard pictures which, with a minimum of configuration, integrate the complete function sequence for process diagnostics into the HMI device concerned. Process diagnostics can run on the following HMI panels: OP or TP27 and 37, OP or TP270, Compact Device C7-626, MP270 and MP370, on each PC with Pro Tool Pro and WinCC, with WinCC, for example, on the Simatic Panel PC FI45.